Koldkatcher manufactures standalone glycol heat tracing systems for remote well site locations. These systems are primarily used in the oil and gas industry where there is limited or no power available. To demonstrate how the freezing effect begins at a typical well site, we need to look below the surface. Formation gas enters the wellbore through perforations in the casing and expands. This expansion causes the gas to lose heat due to the difference in pressures from the formation to the wellbore. The gas flow continues its journey up the wellbore and expands more and more rapidly as it gets closer to the surface. This rapid expansion results in further heat loss and is commonly referred to as Boyle's Law. Upon reaching the surface, the moist gas enters the ambient surface conditions. Daytime temperatures can quickly drop at night, beginning the freezing effect. Gradually, the moist gas and any produced fluids can begin to freeze to the inner wall of the flow line. Over a short period of time, this builds until the flow line becomes completely closed off, resulting in unsafe conditions for the operations personnel and complete loss of production. Once the flow has stopped, the rest of the surface lines begin to freeze, worsening the problem. The Koldkatcher heat trace system prevents this freeze effect from happening by transferring heat along the entire length of the flow line, creating a barrier from the ambient surface temperatures and keeping production flowing. The Koldkatcher is specifically designed for Class 1, Division 1 and 2 heat trace applications for potentially hazardous environments. It is an enclosed-loop, glycol-based circulating system that automatically senses any loss in glycol return temperature and immediately adjusts to maintain consistent heat within the loop. The system requires natural gas or propane as a fuel source. Incorporated into the system is a fuel gas recovery loop that optimizes efficiency and performance. This non-venting feature makes Koldkatcher systems environmentally friendly. Installation begins with placement of the system close to a fuel gas supply source. Half-inch stainless steel tubing is installed along the entire length of the flow line. Installing the tubing near the bottom of the flow line will ensure that the heat will radiate up over the entire surface. Stainless steel banding is then applied every 18 to 24 inches to ensure good contact of the tracer lines to the flow line. All tubing connections of the tracer lines are brought out, so they are not covered by the insulation, to allow for access and to ensure there are no leaks. Insulation is then installed over the flow line and trace lines, creating a small airspace and banded. This small airspace, once heated, will create a barrier from freezing temperatures. Once the supply line gas has been connected, the Koldkatcher heating unit can be started. The unit will begin heating and circulating warm fluid through the trace lines via an exchanger mounted in front of a catalytic heater. The unit will control and maintain the desired setting through fluctuating daily window temperatures. The Koldkatcher heat trace system can prevent costly steam trucks, excess methanol use, preventable equipment damage, unnecessary safety risks to personnel, and lost production due to freeze-ups. The proactive operator quickly sees substantial benefits and revenue, while the reactive operator sees expensive recurring operational costs and continued lost production when demands are at their peak. Integration of these field-proven non-venting heat trace systems throughout Western Canada and the United States by oil and gas companies explains why these systems are rapidly becoming accepted as the industry standard in remote freeze protection.